This video will cover Chapter 2, Fractions. The specific contents will include fractions, addition and subtraction of fractions, addition and subtraction of mixed numbers, multiplication and division of fractions, and converting decimals to fractions and fractions to decimals. Fraction means a part of a whole. Fractions are written in the form of one number over another with a line between the two numbers. As the examples here, you have 5 over 8, 1 over 4, 9 over 7, and 13 over 10. The top number represents the numerator. The number above the line is the numerator. The bottom line is referred to as the denominator. When we talk about the whole, the example you can see is this apple. This apple would be considered a whole apple. If you took a part away from that apple, that becomes a fraction of the apple. And so in this example here, we're removing 1/3, a third of the apple, and what remains is 2/3. If we add the 2/3 and the 1/3 together, we're going to get the whole apple. There are different types of fractions. A proper fraction is also called a common fraction, have numerators that are smaller than their denominators. It's what we expect when we see a fraction. We expect the numerator to be smaller than the denominator. So proper fractions, as an example here, are 1 over 2, 3 over 4, 7 over 13, 91 over 100. We can have what is referred to as an improper fraction. An improper fraction means that the numerator is equal to or larger than the denominator. The example here, we have 3 over 3, 9 over 7, 125 over 4, 13 over 12. If we want to write a whole number as a fraction, it's relatively easy. 25 is equal to 25 over 1, 4 is equal to 4 over 1, and 135 is equal to 135 over 1. You can think of this line that divides the numerator and the denominator as a division sign. A mixed number is the sum of a whole number and a fraction. So for example, 5 and 3 over 8, or 5 and 3/8, is a mixed number, meaning what you have is 5 plus 3/8. Some examples of a mixed number is 17 and 3/5 and 92,407 and 3/4, or 3/4. Often we come across a situation where we need to convert a mixed number to an improper fraction. So as an example here, there are 3 steps associated with converting a mixed number to an improper fraction. The first step is multiply the whole number by the denominator of the fraction. In this example here, the denominator is the 8. 8 times 4, and then we're going to add the numerator. So 4 times 8 is 32, plus the 5 gives us a total of 37, and then we're just going to carry over the denominator from the fraction. So this 4 times 8, 32 plus 5 is 37. That becomes the numerator, and then the denominator carried over, and then the denominator is just carried over from the fraction. Let's go ahead and try to solve for, let's just do one of these, 25 and 3/4. Go ahead and pause this and you can go ahead and solve it, and then when you're ready, we'll play it and go together. So the book talks about taking the whole number and multiplying it by the denominator. That works, but generally speaking, the way it always worked for me, the way I learned how to do this was I started from here and just worked my way this way. So in other words, I'll start here. I know that what we're going to do here is multiply, and then here we're going to just add. So I'll take the 4 times the 25, which is 100, and then I'll add the 3. So my numerator is going to be 103, and then I'm going to carry over the denominator, so the answer would be 103 over 4. The next objective is to convert improper fractions to mixed numbers. So we're going to go in the exact opposite direction of what we just learned. We're going to take an improper fraction and then convert it to a mixed number. And to do this, we're simply going to divide the numerator of the fraction by the denominator. After we've done that, the quotient is the whole number part of the mixed number. The remainder is the numerator of the fraction, and then keep the same denominator in the fraction part of the mixed number. Those are the 4 steps. Let's go ahead and apply them. So 27 over 4 is an improper fraction, and we want to convert that to a mixed number. Go ahead and pause, try to solve, and then you can come back. So in this example, we have 27 over 4. This is an improper fraction, and we want to convert that to a mixed number. To do that, we're going to divide the 4 into 27, or 27 divided by 4. 4, divide that into 27. 4 goes into 27 6 times. 4 goes into 27 6 times. 6 times 4 is 24. We're going to take the 27 and minus the 24, and that's going to leave us with 3. To finish off converting the improper fraction to a mixed number, well, we know 6 is the whole number. So at this point in time, we're going to take the remainder of 3, and that's going to be over the same denominator that we had in the original problem. So the answer is going to be 6 3/4. The next objective is to write a fraction in its lowest terms. You may have an example here where 15 over 25 that's definitely a fraction, but you may be able to automatically see this. In some cases we can, in some cases we can't, but in this case we can see that both of the numbers on the right side end with 5, which tells us that both of these numbers can be divisible by 5. So when we're trying to work with fractions, in almost all cases, it's going to be easier to work with those fractions if they are presented in its lowest term. So as an example, 15 over 25, since we know both the 15 and the 25 can be divided by 5, let's do that, because that's going to end up reducing the fraction to a lower term, to its lowest terms, and that will enable us to use easier numbers to work with. So 15 over 5, since we know that both of those can be divisible by 5, we're going to take this one at a time. 15 divided by 5 gives us 3. 25 divided by 5 gives us 5. The result of us using 5 will give us 3 over 5. So 15 over 25 is equal to 3/5. This is not its lowest terms, but this is. There's no whole number can be evenly divided into 3 and 5. So therefore, this represents the fraction's lowest term. Let's go ahead and use B this time. Try to solve for B, 33 over 39. Pause, and then come back. Okay, so what we have to do is figure out what number can be evenly divided into 33 and 39. This may or may not be obvious to you, but certainly 1 can, but 1 is worthless to us because it won't change this number at all. 2, well, 2 will not work because 2 is an even number and we're dealing with odd numbers. 3, on the other hand, seems to me to be a very good candidate because 3 can be divided into 33 and also 39. So let's go ahead and move with 3 for now and see what happens. So we're going to divide 33 by 3, and then we're going to divide the 39 by 3. So 33, I'm going to do this by a spreadsheet, but you can do this in your heads. You're not supposed to use calculators, remember. 33 divided by 3 is 11. So 3 goes into 33 11 times. And then we'll do 39 divided by 3, and that's going to give us 13. So those are both prime numbers. 11 and 13 are prime numbers, and we'll talk more about that later. But that means that we can no longer reduce these in any way. So unless 11 were to go into evenly into the number, the denominator, then we're done reducing. So the answer to this problem is 11 over 13. There are rules for divisibility that are very helpful for the user of these rules to determine whether a number can be divided by another number. And often this is very helpful if we're trying to solve problems associated with reducing fractions, because we just don't know for sure whether a number can be divided into another number evenly. And so we'll start off with the numbers from 0 to 10. 0 is a non-issue because 0 does not work for division. So we can ignore 0. 1, well, a number divided by 1 is the number, so that's not going to help. So we start with 2. And we can read down through each one of these, and some of these are going to be pretty interesting to learn, and some of them are going to be obvious. So a whole number can be evenly divided by 2 if the last digit is an even number, such as 0, 2, 4, 6, 8. So if the last digit of whatever number you're working with, let's say it's 98, we know that because it's an 8, it can be divided by 2. Whatever whole number you have can be divided by 2 if the last digit is an even number, such as 0, 2, 4, 6, or 8. The whole number that you have can be divided by 3 if the sum of the digits is divisible by 3 with no remainder. I'll give you a quick example of this. Let's say the number you have is 231. So the rule of divisibility tells me that we look at this and we know that it can't be divided by 2 because the last digit is not an even number. So we're going to go throw 2 out. The next question becomes can it be divided by 3? And the rule of divisibility says if the sum of the digits is divisible by 3 with no remainder, then it can be divided into 3. So the sum of the digits, well, what are the digits? We're talking about 2 plus 3 plus 1, 6. The sum of the digits is 6. If the sum of the digits is divisible by 3 with no remainder, then it can be divided by 3. 6 can be divided by 3 with no remainder. All right? So therefore, that would suggest that this 231 can be divided by 3. And it can be divided by 3 evenly, so that you'll end up with no remainder. So 231 divided by 3 is 77. And there's no fraction, it just worked out perfectly. So that's an example of what we mean by the sum of the digits. The next rule, a whole number can be evenly divided by 4 if the last 2 digits are divisible by 4 with no remainder. So the example for number 4 would be, let's say your number is 824 and you're trying to think, well, is this divisible by 4? And the rule says if the last 2 digits are divisible by 4 with no remainder, then it can be divided. Well, you know that 4 can be evenly divided into 24, right? 24 divided by 4 is 6. That's a whole number. So that suggests that 824 divided by 4 will work. And in fact, it is. It is 206. Okay? A whole number can be evenly divided by 5 if the last digit is 0 or 5. I think most of us know this one. You can try it out if you don't remember, but a whole number can be evenly divided by 6 if the number is even and the sum of the digits is divisible by 3 with no remainder. Okay, so we've actually dealt with both of these rules, so we know what they are. If the number is even and the sum of the digits is divisible by 3 with no remainder. So the sum of the digits, just like what we did here, but it has to meet those both of those criteria for it to be divisible by 6 evenly. Divisible by 8 if the last three digits are divisible by 8 with no remainder. And then divisible by 9 if the sum of all the digits is divisible by 9 with no remainder. And then 10 if the last digit is 0. So these rules of divisibility will make it easier for us to make a determination if a specific number can be reduced or can be evenly divided by a specific whole number, including 2 through 10. So let's go ahead and look at A. Determine whether the following statements is true. 3,746,892 is evenly divisible by 4. Go ahead and look, see if you can figure that out, and then come back. Okay, the rule by 4. Let's go look at the rule of 4. The rule of 4 says if the last two digits are divisible by 4 with no remainder. Well, let's look at the last two digits. 92. 92. The question becomes, is 92 divisible by 4? And the answer is yes. You want to check on that? Let's do that. Plus 92 divided by 4. You get an even number of 23. That concludes section 2.1.